Now, there is a process capability matrix. So likewise in discrete, we have calculated DPMO, DPO, DPU, right? But in case of a continuous data, you will not calculate DPO, DPU, DPM. You will calculate CP, which we are going to talk about now, which is CP is referred to process capability. Okay. So we are going to talk about two new concepts today when we are calculating the process capability for a continuous data. For calculating process capability for a discrete data, we learn DPU, DPO, DPMO, and process sigma level. But for a continuous data, we will not do any of these things. In that case, we will calculate CP and CPK. So we will talk about these terms. What is CP and what is CPK? CP means process potential index, okay, which means what is the inherent capability of my process by its design. It tells me, CP tells me whether my process is equipped to meet the customer requirement or not by design. Whether my process by design is strong enough that it would be able to meet the customer requirement. That's what CP tells me. Okay. The formula for CP is USL minus LSL upon 6 standard deviation. Okay, so we'll talk about how this formula is derived as well. But you can only calculate CP when you have both the specification limits. If you have only one specification limit, you will not be able to calculate CP. So there is a prerequisite to calculate CP. You have to have both upper specification limit and lower specification limit. So this is called CP, which is called process potential index. It tells whether my process is capable enough to meet the customer specification which he has specified. The second concept.
Sorry to interrupt. One question here. So here in CP, we are taking in the calculation 6 standard deviation, right?
Yeah.
Okay.
Yes.
Now, when we were doing what you call the previous one, not the continuous data, where we were looking at the process sigma. I fail to understand what will be the standard process sigma that we would be looking at. Like in the examples, we had like 2 point something. So we will consider it as okay, good, bad, like to what we compare it and say that we are fine with it or not fine with it.
So there is no such standard that we follow in the discrete sort of a data, because discrete data has not much variation in the process because it's sort of a attribute data wherein we have true, false, count, number of people, where we have binomial, ordinal, and percentage. Therefore, we don't have any sort of a standard in case of a discrete data. We look at what is the current sigma level or what is the current DPO or DPMO that we are at, and we try to improve that while working on the process. However, in case of a continuous data, we have certain standards that we are going to talk about, that this should meet that certain requirement for us to say that this process is good enough by its design. So we talk about what is that threshold that we look at to say that whether my process is good enough or not. These are the things we don't look in the discrete sort of a data. We only look.
Okay. So in discrete, whatever is the process sigma, the only aim is to understand that this is my sigma level and we should try to improve it. That's the understanding.
Yes, and you should know the logic also, Rimi, that why are we saying it also, because it's not only when if Simarpreet is saying, we should not say that, yes, you're saying a logic behind that is in a discrete sort of a data, we don't have that much amount of variance. Okay. We all know what is a continuous data. So we see there will be a lot of variance in a continuous data where we have 20.5 minutes, 20.51 minutes, 21, 22, a lot of variance. But in a discrete sort of a data, wherein you have majority of the time attributes, pass, fail, false, you would always convert the data into that way. Okay. Wherein you would expect very less variance. In that particular case, we would not be able to see whether my process by design be able to fulfill customer requirement or not. So whatever sigma level I calculate, I go ahead and consider that as a final and try improving that, because there I would not have that much amount of variance for me to look at. But in CP, I will take certain examples to make you understand that why we take a standard in CP, not in discrete data. But just now understand, CP refers to the process potential index, which talks about how my process is capable of meeting the customer requirement. Okay, is it clear to all of us? The only difference is
Yeah.
variation. Okay, so this is what CP is, and another thing which is called CPK. Okay, CPK talks about process performance index, which refers what is the current performance. What is the current performance at which my process is operating? So that's what my CPK tells. So CP tells me the process by design, and CPK tells me the current performance. Likewise, when we calculate the sigma level, it tells me that where I'm currently at. CPK in continuous data tells me where my process currently stands. We don't calculate uh, the sigma level here. We only calculate CP and CPK in continuous data. Okay, so now when we talk about CP, there could be three scenarios. Okay, either your CP is less than one.
Question. I'm sorry to disturb you, but so when it says Six Sigma, we are still considering the standard deviation, right? Because sigma is a standard deviation.
Yeah.
So even for calculating the CP, won't we need to calculate the sigma level?
Okay. So if we look at the CP's formula, I was coming on that after this one. If we look
Sorry.
at the CP formula, can you see the screen?
Yes.
Okay, so let me explain this formula first, and then I'll talk about the three conditions. Okay, CP says USL minus LSL upon 6 standard deviation. 6 standard deviation, which means what my process is currently capable of performing. Okay, when my process, so though we haven't talked about this concept yet, but yes, since you have asked this question, 6, when would I call my process is within the specification, within the normal cause of the time. Okay, we talked about normal distribution. When my process is within plus minus 6 standard deviation from either side, then I would call my process is at sigma level, 6 sigma. Here in that case, since we are not calculating the sigma level, I have taken 6 standard deviation into consideration. I would call 6 standard deviation only when my process is within the normal distribution. So USL minus LSL is my tolerance, and 6 standard deviation is my normal distribution. So here I have taken that angle here, wherein I'm saying that in terms of 6 sigma, how my process is currently at. Does it answer your question?